In this video, I'll be talking about cutting of spring in SHM. So let us take one example. We have a, let's say, spring which has, let's say, n number of coils, like these are n number of coils, and suppose that we cut this spring from the middle position. Okay, so we cut and converted in two springs of turns or coil n by 2 in each, right? So suppose that here we have two elements, so this one is having n by 2 turns, n by 2, or here this one was having n. So obviously this length, let's say length is L and a spring constant is given to be K. Suppose the new one is having a spring constant K dash, then find out the value of K dash. So we want to calculate the value of K dash, right? So understand, for the first spring, this is our first spring, original spring, we know that K is inversely proportional to the length, right? So here we can write is this spring K is nothing else, spring constant. As you know, spring constant depends on the length property of the material, so K is dependent on L. So L can be written as n into L dash, where L dash is equal to L by n. That means clearly this is length per unit coil or turn. So this can be written as n into L dash. Now this L dash will be constant for ideal spring. So if this is constant, that means I can say that K is proportional to n only, or else I can say Kn proportional to 1, or I can say Kn is equal to constant, right? So I can use this term Kn is equal to constant, so I can write K1 into N1 will be equal to K2 into N2. So here if I do that, so I can say K initial, N initial is equal to K final, N final. Here K initial is K, N initial is N, then K final we want to get, which is K dash, into N final is N by 2. So this is cancelled out, so K dash will be given to be 2K, right? This is going to be the value of K dash. So now there can be one further example in this question, like suppose that initially this spring was having time period, let's say T, then can we calculate the time period of T dash while the cutting these two springs are connected into the parallel, right, and series? So yes, this question can be asked further. So what is the question? Initially this spring is like this, length L, spring constant K, mass M is attached. So we know that if this particle does the SHM, then time period is given by T is equal to 2 pi under root of M by K. Okay, this is the time period. Now suppose that I said the condition is that this spring is cut into two parts, as per the previous example, like this, and then these two parts are connected in parallel. So the spring constant was k dash, and these two parts are connected in parallel, and the same block is connected like this. In this scenario, let's say time period is t dash. Can we find the value of t dash in terms of t? So yes, we can find, because we have seen that this spring was having a spring constant 2k. Obviously the other part was also having n by 2 turns, so this will also have the spring constant 2k itself. So now we can find out the value of k equivalent. So these are in parallel, so k equivalent will be k1 plus k2 in parallel combination, right? So this k equivalent for this combination will be k 2k plus 2k, because this will be k dash plus k dash, and k dash will be is equal to 2k, which is 4k. That means t dash is going to be 2 pi under root of m by k equilibrium. So this t dash will be under root of m by 4k. Perfect. So now what I can do, I can take the ratio. So t dash upon t is equal to 2 pi under root of m by 4k upon 2 pi under root of m by k. So this is m by k is cancelled out, 2 pi is cancelled out. This is 1 upon 2, this is 1 upon 1. So t dash upon t is equal to 1 upon 2. So t dash is going to be t by 2. Okay. So we obtained the value of t dash. And suppose that if the same combination was there but in series, so in series we can have the situation, this was cut in two parts, and then suppose they are connected in series. So the situation will be, there is one spring and there is another spring, there is our block of mass m, and similarly this is happening. So we know that k dash is going to be 2k, and here k dash is going to be 2k. We know that for series combination, so for series combination, what is the nature? Yeah, so answer of the parallel was t dash was t by 2 is parallel. And for series combination, here we go, we have k equivalent for two spring system, k1 k2 upon k1 plus k2. So little bit nicely let us write k1 plus k2. Perfect. And here k1 is k dash, k2 is also k dash upon 2 k dash. So this is going to be k dash is cancelled out, this is k dash by 2, and the value of k dash was 2k. So this is cancelled out, so this is going to be simply k. So in series combination, time period double dash is equal to 2 pi under root of m by k equivalent. Here this is coming out to be same, m by k equivalent, which is k, which is equal to t double dash. Of course answer has to be the same only, because nothing else. If you because this point is massless, so you can replace this combination with a straight spring, and for this spring answer is obviously known, t is equal to 2 pi under root of m by k. Okay, so yes, these type of questions can be asked in NEET pretty easily, so I believe you will be able to do such questions. Okay, yeah.